Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 5 on trigonometry. It says, without using a calculator, simplify the following expression to a single trigonometric ratio. So, okay, let's start with that. We have 1, and then we know that sine of a negative angle is negative. But then since we have a negative from outside here, this will be 1 plus sine theta, right? Now, this is a cofunction here. How is cos in the second quadrant? We know that cos is negative in the second quadrant, but then since this is a cofunction, it changes to negative sine theta. So always note one thing about that. It does not depend on the trig ratio that we are going to change to, but then it depends on the trig ratio that we have here, the parent, right? So cos is negative in the second quadrant. Therefore, the trig ratio it changes to needs to also be negative. Now, what we have in the denominator here, we know that this is another form to express your negative angle. So all we have to do to correct that is just add 360 degrees because we are used to either 360 plus theta or 360 minus theta. So not theta minus 360. We have to correct that. It is a negative angle. Then sine theta times negative sine theta, that's 1 minus sine squared theta. And then down here, the negative 360 and positive 360 will just cancel out. Then we are left with cos theta. But then looking at your numerator here, you will remember from grade 11 that we have a trig identity that says 1 minus sine squared theta is equal to cos squared theta. So note that with your grade 12 trigonometry, a lot of the trigonometry, about maybe 70 or 80% of the trigonometry that you'll find in grade 12 is actually based on the grade 11 trigonometry. So it's only just a small percentage of the grade 12 trigonometry. Then at this point, we know that the cos squared theta is just the same as cos theta, and then it's just going to cancel out with one of the cos theta there. Then we are left with cos theta. So we have solved this to a single trigonometric ratio, which is cos theta there. So that was a fairly easy one to do. Now let's proceed to 5.2. We know that every time we are given a question like this, we must just start by drawing a young triangle here, right angle triangle, to just indicate this. So remember, cos 20 degrees, that's P over 1. So that's adjacent over hypotenuse. If we have our 20 degrees here, then our adjacent is here and our hypotenuse is here. So we have to look for this side here, which is our opposite side. And then we know to calculate that it's just y is equals to root r square minus x square, which will give us 1 minus p square. So let's include it here, 1 minus p square, right? Okay, now that everything in the diagram is filled out, then you can start answering the questions that you are given there. So, okay, starting with 5.2.1, we have cos 200 degrees. And then we can see that this here falls within the third quadrant because this is 0, 90, 180, 270, and then 360. So the 200 here is in the third quadrant, whereby we have the reduction formula 180 plus theta. So we can write that as cos 180 plus 20 degrees. Remember, the goal is having to express everything that we see here in terms of this 20 degrees there. Right. Now, how is cos in the third quadrant? We know that it is negative. So we have negative cos 20 degrees. If we know the value of cos 20 is P, then what is the value of negative cos 20? It is negative P. Now, 5.2.2, we have sine of negative 70 degrees. And then negative 70 degrees, sine of any negative value is negative. So negative sine 70 degrees. And then sine, this can be written in reduction formulae as sine 90 degrees minus 20 degrees, which is still the 70. But then remember, I'm trying to express it in terms of the 20 there. So since this is a cofunction, it will change to negative cos 20 degrees. So remember, sine is positive in the first quadrant, but then we have the negative from here. So this again gives us negative p. Now, when we come to this one here, sine 10 degrees, note that the first two questions, they can even be done by a grade 11 student. They are coming from grade 11. So all you just have to do here is apply reduction formulas. But when it comes to the third one that they always have there, this is strictly for grade 12, because it's either you'll be given in terms of a double angle or you'll be given in terms of the compound angle. Now, this one, you cannot do it in terms of your reduction formulas, even if you tried, right? So now we want to check for the relationship between the two angles that we are given. Now, looking at 20 and 10, we can see that 10 here is just a half of 20 degrees. So that means the cos 20 degrees, in other words, is a double angle, right? Now, how can we express the double angle? Remember, the double angle of cos 2 theta, or let me say cos 2a, can be broken down as cos squared a minus sine squared a, or can be broken down to 2 cos squared a minus 1, or 1 minus 2 sine squared a, right? So all of these trig identities are just equivalent to that double angle. Now, remember, we are trying to solve for sine 10. So which one will be more suitable for us to calculate sine 10? We can all agree that it is the last one here, because it is expressed with the trig ratio of sine. Now, what are we going to do? What is our double angle? Remember, we concluded that the cos 20 here now represents the double angle. So if we have 5.2.3, the cos 20 here is a double angle. That means it breaks down to 1 minus 2 sine squared, and half of the double angle is 10 degrees. So remember, what are we looking for? We are looking for the value of sine 10. So I want you to pay attention to the manipulation that will go on here. The cos 20 degrees, remember, we do have its value. It's equals to p. So let's substitute this is p. And then here I have 1. And then minus 2 sine squared 10 degrees, right? Now, if I can just interchange this, let me bring this one over to this side. So this is 2 sine squared 10 degrees, and then I will have 1 minus p, right? Now, to further calculate here, I can just divide both sides by 2, because remember, I'm looking for the sine here to be the subject of the formula. Now, I have sine squared 10 degrees is equals to 1 minus p over 2. But then remember, I'm not looking for sine square, I'm looking for sine 10, right? So I can just square both sides like this. And then now the sine 10 degrees will be equals to root 1 minus p over 2. And that becomes your solution. So note the manipulation that we took there, right, having to solve that. So first we identify that we can break down the double angle to one of this, but then to correspond to give us the sine 10, we chose that the last one was the one was that is more relevant to the question. And then we just try to manipulate until we find that value for sine 10 degrees. So this is the level of understanding or the level of approach that you should have for the questions that are coming for your exam, right? Then let's proceed to 5.3. It says determine without using a calculator the value of all of this, right? Now, you need to be extra careful with this. If you can check, this is a compound angle, this is a compound angle, and then all of these are just compound angles. But then if you can just look at them carefully here, you would find that this is just one angle. This represents one angle. This represents another angle. And the same angle here has been repeated, right? The same angle that you have here has been repeated. So all of this as a whole is just one compound angle, right? So this is just one compound angle. So you don't have to do compound angle for this and then compound angle for that. This whole expression here is a compound angle. So it's a compound angle for what? For cos, because it goes cos, and then plus, and then sine. Now we know that consulting what we have in the back of the formula that says cos alpha minus beta, we know this comes out as cos alpha and then cos beta, then changes the sign to a positive, sine alpha, and then sine beta, which is, if you can just look at this, this is exactly the same, considering that if you take this whole angle here as alpha, and then you take this whole angle here as beta. Now you see the same thing has been repeated. This is alpha, and then this is beta. So you need to be extra careful with these questions. Now that means I can just break all of this here to this compound angle there. So that means I will have A plus 55 degrees and then minus, so let me use square bracket, then minus the whole expression for angle beta, which is A plus 10 degrees. Now you see that this will give us cos, and then if we just break it down, A minus A, that's 0, 55 minus 55 minus 10, that's 45 degrees. Now note, easy piece. Now if you just calculate this from your knowledge of your special angles, you know that it's 1 over root 2. Please do not press it in your calculator, because if you press it in your calculator, it gives you root 2 over 2, which just mainly tells us that you've been using a calculator. So be careful with finding the value for cos 45, because once you press it in your calculator, then we can tell that you've been using a calculator. So, okay, that's how you were just supposed to approach that. So see how easy it is when you just kind of see that whole compound angle there. Then it's just 3 steps like that, and it's equivalent to 3 marks. So nice. Now, 5.4 says consider this whole equation here and then prove the identity. So let's start from the left-hand side and then just go, this is a double angle here. But then at this point, we don't have any ideas as to how we can break that one. So let's just leave it. But then this one can only be broken down to 2 sine x and then cos x. So let's just deal away with that. Minus cos squared x and then over right here we have sine x and then minus 2 cos x, right? So what can we do to solve this one? Looking at this here, you can see that if we can break down this one here, let's try to break down this expression here according to cos squared x minus sine squared x, right? So this is cos squared x. So the reason I'm doing that is because already I'm looking at this and I can see that if I introduce the cos squared x here, it can cancel out with that cos squared x. So in my mind, I'm having a cancellation, right? In my mind, I just want to cancel. I want to deal away with some of the things here, right? Remember here, when you solve this, remember this is simplify, and then you are just trying to break this down to a small bits of information that you can now deal with. So we have minus cos squared x over sine x minus 2 cos x. Now look at this. This can now cancel out with that, right? And then here I'm left with, let's write it as the 2 sine x cos x and then minus sine squared x. And then below I have sine x minus 2 cos x, right? Then this can now be, considering that now I have a common factor of sine x, I can say this now can be a factor out to the sine x. And then, oh, now I see where we are headed. So if we factor out the sine x from this part here, we are only left with 2 cos x, and then minus, if we factor out the sine x here, we are left with sine x, right? Over the sine x minus 2 cos x. So that means if I can just factor out the negative from here, I will have negative sine x over, and then having to express it exactly as it is in the denominator, this is sine x minus 2 cos x. Note that by factoring the negative, I did not change anything, because if I go negative and positive, this will still be the same as the positive and negative that I had here. Now, negative and negative is positive. This is the same as positive and positive that I have. So I simply factored out the negative and then wrote it exactly as it is in the denominator. Then over sine x minus 2 cos x, right? Now at this point, I can see that this expression here is exactly the same as this expression there. So that means they can divide out. Now I'm left with negative sine x, which is what I was trying to prove. So therefore, the left-hand side is equals to the right-hand side. So that's how you were just supposed to approach that question there. It was a very nice question to deal with, right? So was it only 3 marks? What? 3 marks, yo, for all of this. Now determine the value of all of this. So let's see, what are we supposed to do here? Okay, so we have cos 2x plus sine 2x minus cos squared x over, so I'm hoping that they done something from the above question here, now that they're asking us that question. So I think it has something to do with the denominator here. Let's solve. So if we just leave it, we leave this one as it is, minus cos squared x. And then if we factor out the common factors here, we have negative 3. And then this is a negative 3 sine x. And then here we'll be left with the sine x minus 2 cos x, right? So look at this. Remember from the previous question, we determined that this whole expression here, that we are seeing here is equal to negative sine x, right? This whole expression that we are seeing here is the same as this expression here. So it is equal to negative sine x. So that means, having that, we can say that negative sine x over negative 3 sine x, right? Remember, we are only left with this negative 3 sine x, but the whole expression, this whole expression is negative sine x. Now the sine x and sine x will cancel. We have negative 1 divided by negative 3, which is positive 1 over 3. So that's how you were supposed to find that. It was a very nice question. Okay, now let's look at 5.5.1. We are given 3 tan 4x is equals to negative 2 cos 4x. And then now what we needed to do here is just break down the tan. If we say 3 sine 4x over cos 4x, this will be equals to negative 2 cos 4x. So it says, without using a calculator, right, show that sine 4x is equals to negative 0.5. Then if we cross multiply, 3 sine 4x is equals to negative 2 cos squared 4x, right? But then remembering our grade 11 trig identity, we know that if we have cos squared theta, then this breaks down to 1 minus sine squared theta. So it's the same thing. Even if you had cos squared 4 theta, it will break down to 1 minus sine squared 4 theta. So this is 3 sine 4x is equals to negative 2. Then let's break down this to 1 minus sine squared 4x. So the reason we are changing this one to that, it's because we want to make sure that we only work with one trig ratio. And then as we can see here, our solution needs to end up being sine. So which is why we are changing everything to sine. Then this will be 3 sine 4x is equals to negative 2 here, and then this will be positive 2 sine squared 4x. Now looking at this, if we can just take all this to that side, this is 2 sine squared 4x minus 3 sine 4x minus 2 is equals to 0. We now have something that is expressed in the quadratic format, which is ax squared plus bx plus c. You can see it here, your a being represented by the 2, your b being represented by negative 3, and your c being negative 2. So that means we can now factorize this, and then we end up with 2 sine 4x, and then also here we will have sine 4x. Then now we are looking for the factors of 2. So the factors of 2 are 2 and 1. So note how I'm doing this. I'm trying to produce the negative 3. If I say 2 times 2, that's 4. But then if I say minus 1, that's negative 3. So I will have my negative here and then positive here, right? And then this will now give me 2 sine 4x is equals to negative 1. If I divide both sides by 2, and then right here I have sine 4x is equals to 2. But then since we know the properties of a sine graph, its amplitude here, because the a we can see that it is 1, its amplitude will never exceed 1. So always here the range will be an element of negative 1 to positive 1. So that means any number that is beyond that is below negative 1 or beyond positive 1 will not give us a solution. So this here we then need to say not applicable, because this value here for sine 4x, there is no value of x that you can substitute, whereby sine 4x will give you a number that is greater than 1. So we say it's not applicable. But then coming back here, we now have sine 4x is equals to negative 1 over 2, which is exactly as 0.5. So since this one is not applicable, this proves that the only solution is equal to sine 4x is equals to negative 0.4. Which is what we were required to prove. They say show that sine 4x is equals to negative 0.5 is the only solution to the above equation. So this cannot be a solution. That means the only solution that we can have is sine 4x is equals to negative 0.4. And that's how you were supposed to show all of that. Right. Then let's come to 5.5.2. It says hence, remember hence means from whatever that you have proven above, use that to answer this question. So it says, hence determine the general solution of x in the equation 3 tan 4x is equals to negative 2 cos 4x, right? So the hence part simply means that we have already proven from above that the only solution that we have is sine 4x is equals to negative 0.5. So that means this is what we'll be using to calculate our general solution. So we have negative 0.5. Now at this point, we want to calculate our reference angle. But note, the negative here is only indicating that we should choose the quadrant where sine is negative. So sine is negative in the third quadrant and also in the fourth quadrant. But looking for our reference angle, we do not include that negative there. So our reference angle will only just be inverse of sine and then 0.5, right? Like that. So you do not include that negative there. The negative is only directing you to the correct quadrant. Then that's 4x is equals to 30 degrees. Again, at this point, you just want to write reference angle. Please do not try to solve for x here. We are not solving for x. We are looking for the general solutions of x. So that means we'll only start solving for x when we come to the relevant quadrants. So let's start with quadrant number 3. So sine is negative in the third quadrant. That means we will have 4x. And the reduction formulae in the third quadrant is 180 degree plus theta. So this will be 180 degree plus the reference angle of 30 degrees, then plus k 360, because we know the period for the mother graph of sine is 360. then that's 4x, and then equal to, if we add the 2 here, 210 degrees plus k, 360. Now at this point, we want to divide everything throughout by 4. So you see where we start solving for that x. It's right at that point. Then divided by 4, we have x here. This will be 52.5 degrees plus k, 90 degrees, where k is an element of integers. So you see what happened to your period because of this 4 here. So had you solved for the x here, you wouldn't see the change in the period, and then your general solution would end up being incorrect. So always make it a point here. Do not solve for x at that point. Do not solve for x at that point. Then let's look for the general solutions in the fourth quadrant. So again, we have 4x. The reduction formula here is 360 minus theta. So this would be 360 degrees minus our reference angle of 30 degrees plus k, 360, meant to say. And then now we have the 4x is equals to 360 minus 30. That's 330 degrees plus k, 360 degrees. And once again, we divide throughout by this 4. Divide throughout by the 4. Now 330 divided by 4, that's equal to 82.5 degrees. And again, our period is 90 degrees, where k is an element of integers. So now you have found the general solutions in the third quadrant and the general solution in the fourth quadrant. Right. So that's how you are supposed to approach this question for a total of 28 marks. It was a very long question, and then with some challenging questions there and there, but then make sure that you always aim for much more marks in trigonometry, because this topic has a lot of marks, and then make sure that you just practice it very well to master it, and then make sure that you collect as many marks as possible. Okay, guys, and that's it for our lesson today. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.